So guys, today we need to discuss three new terminologies which basically are not new. We have already dealt with them in probability distribution and now it's time to deal with them in binomial distribution. And the terms are mean, variance and standard deviation. Just like we have dealt with the mean, variance and standard deviation of probability distribution, we are going to deal with mean, variance and standard deviation of binomial distribution. Okay? So beginning with, when you have a binomial distribution with you or you have a binomial variate with you, how do you basically talk about its mean? Whether you say you are calculating the mean of a binomial variate or you say that you are calculating the mean of the binomial distribution of that binomial variate, both are going to mean the exact same things. Like it was there in the case of probability distribution as well. Whether you say mean is of the random variable or you say the mean is of the probability distribution of the random variable, both mean the same thing. So what is the mean of a binomial distribution? Let's see. I'm saying let X be a binomial variate. Let X be a binomial variate with parameters N and P. So what do I mean by this? See, whenever this type of a line is written to you, a lot of information is being given to you just by this line. X is a binomial variate with parameters N and P. That means there is a random experiment. So let's understand. There is a random experiment which is performed N times. It's a binomial variate, that means these are N Bernoulli trials. Each trial is independent. As they are Bernoulli trials, each trial has only two outcomes: success and failure. And probability of success in each trial is small p, probability of failure in each trial is small q. This is experiment which is being carried forward. Associated to this experiment is my given binomial variate X. X is a random variable associated to such a random experiment. And what is this denoting? What is this denoting? There is only one random variable or one definition of this function which exists for such an experiment, which is having all these characteristics. And what is the definition of that random variable? X is always going to stand for the number of successes in N trials. Number of successes in N trials. X can assume values 0, 1, 2, 3, 4 and so on up till N. These are all the values which capital X can assume, because in N trials you can have 0 successes or 1 or 2 or 3 and so on, at the max all N successes. So these are the values which can be assumed by X, and therefore after this step I can talk about the binomial distribution of this random variable. But because this is not any random variable, this is actually a binomial variate, right? Because it is representing the number of successes in N Bernoulli trials of this random experiment. So it is a binomial variate. So it is going to lead to the construction of a binomial distribution. This is X, this is Px. X can assume value 0, 1 and so on up till N. What is the probability of capital X equals 0 is going to come over here, probability of capital X equals 1 is going to come over here, and so on. Probability of capital X equals n is going to come over here. Now understand, if I say R can take values 0, 1, 2, 3, 4 up till n, I want probability of X equals R, that means probability of getting R successes in n trials. Over here will come probability of getting 0 successes in n trials, probability of getting 1 success in n trials, and so on, probability of getting n successes in n trials. I have kept that variable as R, which varies from 0 to n, and I am generally evaluating the probability of getting R successes in n trials. We know that this is equal to what? NCR P to the power R Q to the power n minus R. Now please understand what all are the things which are needed by this formula. You should have n, you should have p, you should have q. Why am I not saying you should have R? You know that if there are n trials being performed of a random experiment, which are Bernoulli trials, very clearly R is going to vary from 1 to n. So I know what all values R can take already if I know how many times the experiment has been performed. I over here know that n Bernoulli trials of the experiment are performed, so R can vary from 0 to n. So I am not writing that you should know R as well. I know that R is a variable varying from 0 to n, where n is the number of Bernoulli trials. I should have n, I should have p, I should have q. What is the relationship between p and q? P is the probability of success, q is the probability of not success. Clearly p plus q is 1. If you know p, you can get q as 1 minus p. If you have q, you can get p as 1 minus q. So to get this particular thing, I only need n and p. If I have n with me, this value is there with me. If I have p with me, this value is also there with me, and q is also there with me, because p, if I have 1 minus p, will give me q. N already I have, and I know R can vary from 0 to n. So for any value of R, I can get the very value of probability of getting R successes in n trials. That means probability of getting R successes in n trials can be obtained very easily just by having these two parameters n and p. Are you understanding? That is why only two things you need to calculate the probability of R successes in n trials. Clear? That is why when I say that X is a binomial variate with parameters n and p, this means what? This means there is some random experiment whose n Bernoulli trials are performed. Small p, small q are the respective probabilities of success and failure. X is a random variable associated to such a random experiment. Therefore, X is going to stand for number of successes in n trials. Therefore, X can take values all these, and therefore the binomial distribution which is going to come up would be this. Now see again, for R equals 0, if you put over there, you get NC0, P to the power 0, Q to the power n minus 0. Here you get NC1, P to the power 1, Q to the power n minus 1, and so on. NCn, P to the power n, Q to the power n minus n. Are you understanding? This is P1, this is P2, and so on. This is Pn. This is x1, x2, x3 up till xn, where I can have a general formula, a general function describing each value over here, that is probabilities, which is this function. This is known as probability distribution function. If I have n and if I have p, what I am trying to say is if I have n and if I have p, I have this complete distribution with me. Right? Because if I have n and if I have p, I can calculate q, right? And I know that R is going to vary from 1 to n, so from 0 to n. So for any value of R from 0 to n, I can calculate probability of getting R successes in n trials. And therefore, I can get the complete binomial distribution of that particular random variable x. Okay? So that is why whenever it is written that x is a binomial variate with parameters n and p, this means X follows a binomial distribution. Which binomial distribution it is following? That is, what is the binomial distribution it is following? it is following this binomial distribution. X is a binomial variate with parameters n and p. That means there is a random experiment which is performed n Bernoulli trials. So R is going to vary from 0 to n. R is all the values which this random variable can assume, because X over here is representing the number of successes in n trials, which can be 0, 1, 2, 3 up till n. So 0, 1, 2 and so on n. This is x1, x2, x3 up till xn, or I can say x0, x1, x2 up till xn. Here what is going to come? P1, P2, P3 up till Pn. What are my probabilities? Probability of getting capital X equals 0 is what? Because it is a binomial variate with parameters n and p, I have a direct formula to get probability of R successes in n trials. I just need n and p to actually get that probability. If I have n, if I have p, n is known, p is known, q is nothing but 1 minus p. Probability of x equals R is n I know, R I know varies from 0 to n, p I know, q I know. And this is true for all R varying from 0 to n. Therefore, what is this? As I had written just now, this is NC0. If you put R equals 0, NC0, p to the power 0, q to the power n minus 0, NC1, p to the power 1, q to the power n minus 1, NC2, p to the power 2, q to the power n minus 2, and so on, NCn, p to the power n, q to the power n minus n. Just this line is giving you a lot of information. Clear? Just with n and just with p, you can calculate the entire binomial distribution. Now let's move ahead. The target is to get the mean of this binomial distribution, or to get the mean of this binomial variate whose parameters n and p are known. Now, what can we do? See, binomial distribution is nothing but a special type of probability distribution only, wherein the probabilities are nothing but the terms of the expansion, binomial expansion of q plus p to the power n. So right now, this is a probability distribution only, where this is x0, x1, x2 and so on up till xn, all the values which capital X random variable is assuming. And this is small p1, p2, or let me write p0, p1, p2 and so on, pn, which are the probabilities corresponding to all these values. Clear? So if I consider this as the probability distribution corresponding to the random variable capital X, that is true, not a wrong statement. So what is the mean of that random variable capital X, or the mean of this probability distribution? We have already done this. This is equal to summation pi xi. Here I is varying from 0 to n. P0 into x0 plus P1 into x1 plus P2 into x2 and so on till Pn into xn. This is equal to this. Right. Now let's try to change the scenario. What is x0? x0 is 0, p0 is nc0, p to the power 0, q to the power n minus 0. What is x1? x1 is 1, p1 is nc1, p to the power 1, q to the power n minus 1. What is x2? x2 is 2, p2 is nc2, p to the power 2, q to the power n minus 2 and so on. What is xn? xn is n, pn is ncn, p to the power n, q to the power n minus n. Let us now write this in the compact form. I can write this as 0, 1, 2 and so on till n. I can write it as R NCR P to the power R Q to the power N minus R. R is going from 0 to N, right? For R equals 0, this will be 0 into NC0 P to the power 0 Q to the power N minus 0, plus for R equals 1, it will be 1 into NC1 P to the power 1 into Q to the power N minus 1, and so on till N into NCN P to the power N Q to the power N minus N. So I can write it in compact form like this. Now let's evaluate. So please keep in mind the mean in compact form of a binomial distribution is given like this. In the form of summation, it is given like this. Now let's resolve it further. Mean is summation R into NCR P to the power R Q to the power N minus R, where R is varying from 0 to N. How can I write this further? Let's see. You know that NCR can be written as what? If you remember, NCR is equal to N by R. You take one N and one R, you are left with N minus 1 C R minus 1. Right? I already have an R over here, so bringing an R in the denominator is going to help me cancel this R. So that is why I am using this relation. We've already done this, proved this. This will be N by R, N minus 1 C R minus 1, P to the power R, Q to the power N minus R. Now let's do some changes, some modifications so that the process is simplified for us. P to the power R I have. I want R minus 1. Can I write it as P to the power R minus 1 plus 1? Same thing. This, if I club these together, I get P to the power R minus 1 into P to the power 1. X to the power M into X to the power N is X to the power M plus N. So this is what I get. So that means I can write P to the power R as P to the power R minus 1 into P. Let's talk about Q. Q to the power N minus R. Right. Can I write it as plus 1 minus 1, N minus R plus 1 minus 1. Now N and minus 1 I am clubbing together, N minus 1 minus R plus 1, so minus common R minus 1 in the brackets. So you have N minus 1 minus R minus 1, which gives me N minus 1 minus R plus 1, which is N minus R. So I can write N minus R as Q to the power N minus R as Q to the power N minus 1 minus R minus 1. If I apply these changes, that P to the power R can be written as P to the power R minus 1 into P, Q to the power N minus R can be written as Q to the power N minus 1 minus R minus 1. What is this step going to lead me to? Let's see. R cancels, N is a constant, N comes outside. It is not dependent on R. Now I have N minus 1 CR minus 1. P to the power R can be written as P to the power R minus 1 into P. Q to the power N minus R can be written as Q to the power N minus 1 minus R minus 1. Again this P is a constant, it is going to come out. So you have N into P left. Summation R equals 0 to N. N minus 1 CR minus 1. P to the power R minus 1, Q to the power N minus 1 minus R minus 1. Try to understand. NCR P to the power R, Q to the power N minus R going from 0 to N is Q plus P whole to the power N, because this is nothing but the expansion of that only. If I replace N by N minus 1, R by R minus 1, what is it that I have? What is it that I have? N minus 1 CR minus 1, P to the power R minus 1, Q to the power N minus 1 minus R minus 1. This is nothing but the expansion of Q plus P whole to the power N minus 1. So NP I have carried forward. This whole thing is actually the expansion of Q plus P to the power N minus 1, binomial expansion. But we know that P plus Q. Why? Because P is the probability of getting success in each trial. So 1 minus P is, that is Q. So P plus Q is 1. 1 to the power n minus 1 is 1 only. And this is your mean. So if X is a binomial variate with parameters n and p, just multiply the both of them, you have the mean. You don't need to calculate the entire binomial distribution and then talk about adding up the respective probabilities with the respective values. No, you don't need to do all of that like you were doing in the probability distribution. Here the process is very much simplified. Just multiply the number of Bernoulli trials with the probability of success in each trial. And you have the mean with you. Very easy formula, n into p, but this is only valid for binomial distribution. Clear? So mean of a binomial variate with parameters n and p is given by n into p. Clear? If mean is understood, let us move ahead with understanding variance. Let's move ahead with understanding what is variance. Now again I am going to use the same logic. What logic I am going to use? I am going to use the same logic, means we were using or basically considering that this particular table that you can see is representing, this tabular representation is of all the values which the random variable x is assuming, and below are their corresponding probabilities. That means this is a probability distribution. Right. So this is a probability distribution. If this is a probability distribution in the very first place, leave alone that okay, what are the probabilities, what are the values, what is this capital X, what are the parameters, what is the very thing that is happening with the random experiment, Bernoulli trials, everything if kept aside. Right now this is representing a probability distribution. X is a random variable which is assuming all these values and these are its corresponding probabilities, that is it. So now, what will be the variance of X? What will be the variance of X? Now, variance of X is also denoted like this. What will be this equal to? If you remember the very formula of variance for probability distribution, because this is also probability distribution, the same formula works. It is summation pi xi square I running from 0 to n minus summation pi xi I running from 1 to n 0 to n actually whole square. This was the formula of variance which we have proved in our very case of probability distribution, where what is this? Summation pi xi. Summation pi xi is actually the mean. So here what you are writing is mean square. This is mean of a probability distribution. This is x bar. So this is actually mean whole square. Now let's try to change the values accordingly as we have them. So summation I running from 0 to n, or rather than that, let's try to understand it by opening this up. This will be P naught x naught whole square plus P1 x1 whole square plus and so on Pn xn whole square minus mean whole square. What is the mean when x is a binomial variate with parameters n and p? It is n into p. We just evaluated n into p, mean square. Clear? Now over here see, what is x naught? X naught is 0. So you have 0 square into p naught, which is nc0, p to the power 0, q to the power n minus 0, plus x1 square, x1 is 1, 1 square p1 is nc1, p to the power 1, q to the power n minus 1. Then x2 whole square, x2 is 2, nc2, p to the power 2, q to the power n minus 2, plus and so on. xn is n square, pn is ncn, p to the power n, q to the power n minus n. this is what you have, minus NP whole square. Now compactify it and write it. When you compactify it, what do you get? See, 0 square, 1 square, 2 square and so on till n square. I can write it as summation r square. Then you have nc0 p to the power 0 q to the power n minus 0, nc1 p to the power 1 q to the power n minus 1. So you can write ncr p to the power r q to the power n minus r. R is varying from 0 to n. When r is 0, you get 0 square nc0 p to the power 0 q to the power n minus 0. It is here. Summation is there, so plus when r equals 1, you get 1 square nc1 p to the power 1 q to the power n minus 1, which is this, and so on till r equals n max, n square ncn p to the power n q to the power n minus n, which is this. Minus, so this whole thing minus np whole square. Now, what is this? It's very interesting. I can write r square as r square minus r plus r. Not a problem. And I have NCR p to the power r q to the power n minus r minus np whole square. So here what is going to happen is, let me rub this. Here what is going to happen is you will get summation r going from 0 to n. From here you can see r is coming out common. When you take out r common, you are left with r minus 1 plus r. Clear? And then you have NCR p to the power r q to the power n minus r minus np whole square. Now see, this complete is one term. Something plus something times this is these times this and this times this. So just open the brackets up. You get r into r minus 1 times NCR p to the power r q to the power n minus r plus r times NCR p to the power r q to the power n minus r. This complete thing is inside the summation. R minus 1 times this plus r times this minus this is let alone np square. So if this plus this is inside the summation, I can break the summation up with both the terms, summation of this plus summation of that. So what is it that I get is, I get this is equal to summation of r into r minus 1 NCR p to the power r q to the power n minus r plus summation r into NCR p to the power r q to the power n minus r minus np whole square. So what is it that you have? You have summation r going from 0 to n, r into r minus 1. Now to cancel out r, in the case of mean, we had written NCR as n by r, n minus 1 CR minus 1. But I want to cancel out r minus 1 also, so n minus 1 CR minus 1. See, what I am trying to say is NCR can be written as n by r, then 1 less, n minus 1 CR minus 1. And then n minus 1 CR minus 1 can be written as n minus 1 upon r minus 1, 1 less, n minus 2 C r minus 2. So let's write it down, NCR like this. NCR will be n by r, n minus 1 CR minus 1, which is further n minus 1 upon r minus 1, n minus 2 C r minus 2. So that I can cancel out r minus 1 and cancel out r. Now, this is p to the power r, q to the power n minus r. Over here, right? Now let's try to understand few things before I write anything further. First of all, p to the power r can be written as p to the power r minus 2 plus 2. Why 2? Because I am having r minus 2 over here already. So this is equal to p to the power r minus 2 into p square. I can write p to the power r as p to the power r minus 2 into p square. First thing. Q to the power n minus r can be written as q to the power n minus r minus 2 plus 2, which can be written as q to the power n minus 2 minus r minus 2. So I can write q to the power n minus r alternatively like this. Moreover, what is this particular summation? Let's see. Summation r into NCR p to the power r q to the power n minus r. What is this summation? I had just told you in the previous case, if you open this up, you will get for r equals 0, 0 into NC0 p to the power 0 q to the power n minus 0. For r equals 1, you will get 1 into NC1 p to the power 1 q to the power n minus 1 plus and so on. Last is for r equals n, you get NCn p to the power n q to the power n minus n. This is nothing but x naught into p naught plus x1 into p1 plus x2 into p2 and so on xn into pn, which is nothing but the mean of the random variable x. This is equal to mean, right? So once these three things are there with us, a lot of simplification can be done, right? What all simplification can be done? Let's see. So I have these things with me. N and n, so okay, so I had just first of all written this term plus. What is this bracket? We just saw it was the mean. What is mean? Mean is NP. We just proved mean of the random variable x, which is actually binomial variate with parameters n and p, is n into p minus np whole square. Clear? Now, if you can see n and n minus 1 are constants, I can take them out of the summation sign. So I have n into n minus 1, then you have summation r going from 0 to n. You have n minus 2, c r minus 2. Now p to the power r can be written as p to the power r minus 2 into p square. And q to the power n minus r can be written as q to the power n minus 2 minus r minus 2. This is one term. Minus np minus np. This is plus np minus np whole square. Clear? Now again you can see this p square is a constant, it can come outside the summation. What is it that you will be left with? You have n minus 1 into p square. Then you have summation r going from 0 to n minus 2 c r minus 2 p to the power r minus 2 q to the power n minus 2 minus r minus 2. What is this? See again, n minus 2 cr minus 2 p to the power base q to the power n minus 2 minus r minus 2. This is nothing but, okay, so this also has a plus np minus np square. What is this summation? Summation is actually q plus p to the power n minus 2. This is what I have replaced with this summation, right? Now q plus p is 1. So this complete term is going to be 1, 1 into anything, 1 into this complete thing is this complete thing only. So this is n into n minus 1 p square plus np minus n square p square. Simplify, this is n square minus n into p square plus np minus n square p square. This is n square p minus np plus np. So this is np square, yes. So this is n square p square minus np square plus np minus n square p square. This n square p square cancels. You are left with np minus np square. Np comes out common, you have 1 minus p, but p plus q is 1, so 1 minus p is q, and therefore npq is your variance. If x is a binomial variate with parameters n and p, the mean is n into p, the variance is n into p into q, where q is 1 minus p. And what is the standard deviation? What is the standard deviation? It is something that you already know. Standard deviation denoted by SD or sigma x is nothing but positive square root of variance of x, which is positive square root of npq. Clear? Let's deal with the question. I am saying that a coin is tossed thrice, or let me say a die is tossed thrice. Now when you have a die with you and you are tossing it for the first time, that's the first trial, then tossing for the second time, that's the second trial, tossing for the third time, it's the third trial. Whatever you are getting in the second trial is not dependent on what you are getting on the first trial, and so on. Therefore, there are three trials basically, and they all are independent. It is given in the question that getting an odd number is a success. Getting an odd number is a success. Each particular trial can land up in an odd number or not land up in an odd number. If the outcome comes out to be 1, 3 or 5, that means you get success. If the outcome comes out to be 2, 4 and 6, that means you get a failure. So in each trial there are only two possible outcomes: success, failure, success, failure, success, failure. Right? So two outcomes. Success, failure. Success is getting an odd number. Failure is not getting an odd number, that is getting an even number. Now in each trial, what is the probability of success? Probability of success is probability of getting an odd number in any one throw, in any throw of a single die. 3 favorable outcomes, 1, 3 and 5. Total number of outcomes are 1, 2, 3, 4, 5, 6. 3 by 6. 1 by 2 is the probability of success in each trial, and probability of failure is 1 minus 1 by 2, which is again 1 by 2, or you can say what is the probability of getting an even number in a single throw of a die? It is again 3 by 6, because 3 favorable outcomes, 2, 4 and 6, and total number of outcomes are 6, 1, 2, 3, 4, 5, 6. So 3 by 6 again, that is 1 by 2. The setup is like this. Clear? You were just given two things. What were you given? This you were given, and you were given that getting an odd number is a success. Thrice, if you know that an experiment is performed, that means n you have, number of Bernoulli trials, n you have, what is n? N is 3. And if getting an odd number is success, you can very easily calculate small p, which is the probability of success in each trial, which we have calculated as 1 by 2. You have n, you have p, life is very, very good. I don't need anything more. Now I can have q also, which is 1 minus p, which is 1 by 2. We already have evaluated it. And r I know can vary from 0, 1, 2 up till 3. So, in 3 trials of tossing this die, probability of getting R successes in 3 trials is 3CR P to the power R Q to the power N minus R, 3CR half to the power R half to the power N minus R, that is 3 minus R. This is 3CR half to the power 3, which is 3CR 1 by 8. Now, if somebody asks you for what is the probability of getting 0 success, 1 success, 2 success, 3 successes, you can just plug in that value over here and you have your answer. My question is, what is the variance of x? X is a binomial variate associated to this binomial or associated to this random experiment. Variance of x is actually NPQ, because x is a binomial variate with parameters n and p. You also have q with you, NPQ becomes 3 into 1 by 2 into 1 by 2, which is 3 by 4. Clear? What is the mean? Mean is n into p, which is 3 into 1 by 2, that is 3 by 2. And what is the standard deviation? It is square root of variance of x, which is square root of 3 by 4, which is root 3 by 2. This comes out to be 0.87. And that's how you deal with the questions. The only thing you need to determine is n and p, and after that you have your NPQ, NP, and therefore standard deviation. We are going to meet in the next class, which will probably be our last lecture of this chapter. So I'll see you then. Thank you.